Hi, my dear students. We are going to chapter-wise concept. That chapter is trigonometry. The topic is periodicity and extreme values in the graph. Now we are going to identify the period of various types of functions. Now we are going to find the period of fractional part of x. Fractional part of x are denoted by f of x is equal to so this is the symbolic notation of fractional part of x. So fractional part of x is nothing but x minus integral part of x. So this is called fractional part of x. Fractional part of x. Now this part is called this part is called integral part of x or step x. Integral part of x or step x. Step x. It is a step function. So integral part of x gives the integer function. So that means integral part of or step of 1.2 is equal to step of 1.9 is equal to step of 1.33 is equal to step of 1.8 is equal to 1. Similarly, step of minus 2.5 is equal to minus 2.9 is equal to minus 3. That means n less than or equal to step x less than or equal to strictly less than n plus 1. This is the definition of the step function. Definitely it gives integer. So it is called greatest integer function. That's all. So these are the examples for that means it gives definitely integer. So step of 2 is equal to 2 and step of minus 5 is equal to minus 5 and step of 0 is equal to 0. So this is the definition of the, that means this is the derivation part of integral part of x. Now we are going to fractional part of x. That means these are the derivations of describes of fractional part of x and integral part of x. Now we are going to fractional part of x definition. Now this is fractional part of x. That's why the domain for this one is all real numbers. Now range is, suppose you have to substitute fractional part of 2. It is 2 minus step of 2. So 2 minus step of 2 is nothing but 2. That's why it is 0. Now, suppose you have to write 2.6, fraction part of 2.6, that is 2.6 minus step of 2.6. So 2.6 minus step of 2.6 is nothing but 2. That's why 2.6 minus 2 is nothing but 0.6. That's why domain is real number set. Now fractional part of minus 3.8 is equal to minus 3.8 minus of step of minus 3.8. Now this is minus 3.8. This is minus of minus 4, that is plus 4. That's why this is 0.2. That's why domain for fractional part of x all real number set, but range is range means fractional part of x, f of x. Suppose you have to take it as f of x, then f of x belongs to closed 0 to open 1. Closed, this is a closed 0 to open 1. This is not approached to 1. That's why 0.999. That's why this is the range of the fractional part of x. That's why integral part of x is nothing but It gives strictly integer function. It is called greatest integer function, and it is called step function, and it is called integral part of x. Now fractional part of x is nothing but x minus of integral part of x. Now we have to identify the period for this particular function. This is very, very important. Okay. So according to these examples, we have to identify the period of fractional part of x. Now we have to define the period of f of x is equal to fractional part of x. That's why fractional part of x is called x minus step x. So we have to define the period. So according to the definition of the period, f of x plus p is equal to f of x, where p is the least positive real number which satisfy f of x plus p is equal to f of x. Then p is the period which is the least positive real number. So according to the definition of the period, so we have to write the definition of the period, that is f of x plus p is equal to f of x, where p is least positive real number, least positive real number, where p is the least positive real number. According to this definition, so we have to take f of x plus 1, x plus 1, that is x plus 1 minus x, step of x plus 1. Actually, step of x plus 2, suppose we have to take step of x plus 2. Step of x plus 2 is nothing but step of x plus step of 2. So step of x plus step of 2 is nothing but 2, since 2 is integer. That's why integral part of x gives integer, again it gives integer. So according to this, this is x plus 1 minus of, here we have to write minus step x minus step 1. That's why x plus 1 minus the step x minus 1. Now here 1 minus 1 gets cancelled. 1 minus 1 gets cancelled. Then x minus step x. That's why f of x plus 1 is equal to x plus x minus, this is nothing but x minus step of x is nothing but f of x. That's all. Now f of x plus 1 is equal to f of x. We will compare it with f of x plus p is equal to f of x, where p is equal to 1 is a period. Is period of f of x. Okay. So similarly for 2 and 3, 4 like this. F of x plus 2, that is x plus 2 minus the step of x plus 2. So it is x plus 2 minus x minus step x minus 2. Here 2 gets cancelled. Again it gives f of x minus the step of x. That's why f of x plus 2 is equal to x minus step of x. So f of x plus 2 is equal to f of x. That's why for all real positive integers, so for this function, in place of p, 2, 3, 4, 5, 6, 7, 8, these are all satisfied this function, So 1, 2, 3, 4, 5, 6, so on. These are all satisfy this function f of x. That means f of x is equal to fractional part of x, and least among them is 1. That's why 1 is the period of this function. Have you clear? Have you clear? Since according to the definition of the step function, the step function it gives it is nothing but greatest integer function or integral part of x or step function, and fraction part of x it gives minimum 0 and maximum, that means open 1. That's why closed 0 to 1, that is the range. And step function domain is R and range set of integers. Step function range set of integers. So that's why it gives definitely integers such that n less than or equal to step x strictly less than n plus 1. So here the period of integral fraction part of x is called 1. Since 2 satisfied, 2, 3, 4, 5, 6, 7, these are all satisfy this function except, that means least among them is 2. Least among them is 2. That's why least among them is 1. That's why 1 is the period for this function. Okay, that's all. If the function in the form of f of 1x plus or minus f of 2x by f of 3x plus or minus f of 4x, then the period of f of x is equal to, then the period of f of x is LCM period of f1x, f2x, f3x and f4x. That means we have to identify the period of individual functions involving this ratio. So LCM period of all these functions is called the period of the required function f of x. That's why we have to identify the individual periods. That's why LCM period of all these functions is called the period of a total function. That's why if the function always in the form of f of x is equal to f1x plus or minus f2x plus f2x whole by f3x plus or minus f4x, then the period of f of x is nothing but LCM period of all these functions. Okay, so what are the periods, what are the functions involving in the total function in the ratio? That means LCM period of these functions is called period of the total function, right? Now we are going to some examples on these concepts according to the period, right? Now some standard formulae on different types of functions, period of different types of functions. So standard results, period of sin ax plus b is 2 pi by mod a, where a comma b any real number. That means where a is any real number. So this satisfied. That means we have to take the period of the function definitely with the coefficient of x. Give the preference for coefficient of x. That's why period of cos ax plus b is 2 pi by mod a. Since sin x period is 2 pi, that's why sin ax period is 2 pi by mod a. Okay, cos x period is 2 pi, cos ax period is 2 pi by mod a. Like that. So period of secant ax plus b is 2 pi by mod a, and period of cosecant ax plus b period is 2 pi by mod a. Since secant ax period is secant x period is 2 pi, secant ax period is 2 pi by mod a. Now we have to take the coefficient of x here in denominator. So cosecant x period is 2 pi, that's why cosecant ax plus b period is 2 pi by mod a. Now tan x period is pi, actually, that's why tan ax plus b period is pi by mod a. And cot ax plus b period is pi by mod a. Since cot x period is pi, that's why cot ax plus b period is pi by mod a. And period of step x, period of fractional part of x. Fractional part of x is nothing but x minus step x. That's why its period is 1, already proved. Now period of ax minus, that means the fractional part of ax. Period of fractional part of ax is nothing but ax minus step of ax period is 1 by a. So suppose the function in the form of f of x is equal to f1x plus or minus f2x plus or minus f3x whole by f4x plus or minus f5x plus or minus f6x, then the period of f of x is LCM of period of all these functions f1x, f2x, f3x, f4x, f5x and f6x. That's all. So these are the standard formulae for finding the period of the function. Okay. Now we are going to do the questions on the concept. We have to learn about the questions on this concept. Now observe the question, period of cos x plus 2x plus 3x plus so on plus nx for all x belongs to R and n belongs to Z plus is. First option 5 by n into n plus 1, second option 2 pi by n into 2 pi by n plus 1, third option 4 pi by n into n plus 1, and fourth option 1 by n plus 1. Now observe the question, all of you. So period of cos x plus 2x plus 3x plus up to so on nx for all x belongs to R, where x is real number set, x belongs to R, and n belongs to z plus, n is a positive integer, z plus means a positive integer. That's why first we have to take the function. Now solution for this question, cos x plus 2x plus 3x plus so on up to nx. So we have to take a common x from this. So cos 1 plus 2 plus 3 plus so on up to n into x. That's why observe this is cos of, here 1 plus 2 plus 3 plus so on plus n means sum of natural numbers. It represents sigma n. Sum of natural numbers represents sigma n of x. So we know the formula for sigma n, that is n into n plus 1 by 2. Sigma n is n into n plus 1 by 2. Sum of all natural numbers, n into n plus 1 by 2. For this one, cos of n into n plus 1 by 2 x. Right. Now this will comparing with cos ax, where in place of a, n into n plus 1 by 2. That's why comparing with cos ax. Of course cos ax plus b, but b is 0. Cos ax. Then a is equal to n into n plus 1 by 2. That's why in place of a, that is n into n plus 1 by 2. Now what is the period of cos ax? Period of cos ax is period of cos ax is 2 pi by mod a. 2 pi by mod a. According to this formula, 2 pi by n into n plus 1 by 2. Where n is positive integer, there is no chance for negative. That's why no need to write mod. So it is 4 pi by n into n plus 1. That's why that is in third option. That's all. So like this we have to do the questions according to the standard forms of period of functions. Right. We are going to the next question. Now the next question, that is a period of 2 sin x plus 3 cos x by 2 whole by 4 tan 2x minus 7 sin 3x is. First option pi, second option 2 pi, third option 3 pi, fourth option 4 pi. Now observe, take the function, solution for this, f of x is equal to, let us consider this function taken as f of x, that is 2 sin x plus 3 cos x by 2 whole by 4 tan 2x minus 7 sin 3x. Now we have to identify the period of each function involving in f of x. That's why f of x is, that means it represents a numerator and denominator. In numerator sum of 2 sin x and 3 cos x by 2, and denominator that means difference of, that means subtraction of 4 tan 2x minus 7 sin 3x. That's why we have to identify the period for this one. That means we have to identify period for each function, individual period for each function. After that we have to identify the period of f of x is nothing but LCM of all these periods. That's why according to the definition of the period, sin x period is 2 pi. That's why we have to write all these periods. Period of sin x or 2 sin x. Period of 2 sin x is 2 pi. Next, period of 3 cos x by 2 is 2 pi by 1 by 2. According to 2 pi by mod a. Since cos ax period is 2 pi by mod a, From this is 4 pi. Now this is taken as a P1, this is taken as a P2. Now period of 4 tan 2x, period of 4 tan 2x is pi by mod 2. That means according to the period of tan ax is pi by mod a. From this it is pi by 2. That's why this is taken as P3. Now period of minus sine 7 3x. No problem. Sine 7 3x. 7 sine 3x. 7 sine 3x is, that is 2 pi by 3. According to the period of sine ax, 2 pi by mod a. That's why it is 2 pi by 3. So it is P4. Now LCM period of P1, P2, P3, P4 is nothing but period of f of x. Now required period of f of x is LCM of period of P1 comma P2 comma P3 comma P4. LCM of P1, P2, P3, P4. That is 4 pi. Since 4 pi is the period of this, since this is 2 pi, 4 pi, pi by 2 and 2 pi by 3. That's why 360 and 720, 90 and 120, for all these the period is 4 pi. That's why that is the fourth option. Okay. That's why LCM period of all the periods, individual periods, is nothing but the period of the required function. Are you clear? That's all. Now we are going to another question, that is the period of sine x plus 3x plus 5x is first option pi by 9, second option 2 pi by 9, third option pi by n plus 1 and the fourth option 2 pi by n into n plus 1. So sine add them, x plus 3x plus 5x is 9x. So according to the period of sine ax, 2 pi by mod a. That's why 2 pi by 9. So 2 pi by 9 is the period, that is in second option. That's all. Now I will give you practicing questions. You can practice all those questions. Now solve these practice questions. Find the periods of the following functions. So these are the given functions, supported questions, and their respective answers are there, corresponding answers are there. So according to the definition of the period and according to the standard formula of the functions, you can do the questions. Okay, right. Bye bye.